Okay, so the last part of polyatomic ions that we haven't covered yet has to do with when they bring in a hydrogen and they put it immediately in front of the polyatomic ion. Okay, this is going to happen relatively infrequently, but what I need you to understand is how to write the formula and how to name it. So let me give you an example. If you've got a hydrogen attached to carbonate, okay, so when you bring these two things together, what happens is they add the charges together. So a positive 1 and negative 2 would be a negative 1, agreed? So you would get HCO3 negative 1. So whenever you see something like this and you go to name it, you have two options. You can either name this the hydrogen carbonate ion, so that would be 3 words, or you can use bi immediately in front of carbonate, and the bi implies that there is a hydrogen attached. So this would be called the bicarbonate ion, and bicarbonate would be 1 word. Okay. Another example would be if they put a hydrogen in front of sulfate. So if you have a hydrogen ion in front of sulfate, that would be HSO4 negative 1. You could call this the bisulfate ion, or you could call it the hydrogen sulfate ion. Both are completely acceptable. Okay. All right, so that's the end of polyatomic ions. Now, let's move on to putting polyatomic ions into ionic compounds. So we're going to take a look at the next set of practice problems that are in your book. So let's turn to right here. Now what they've done is they've mixed together ionic compounds, and some of these contain monoatomic ions and some of them contain polyatomic ions. So let's take a look at the first one. We've got barium sulfate. So barium is Ba with a +2 charge, so on the left-hand side of the periodic table. Sulfate, there must be an oxygen attached to sulfur. So what would the formula and charge be for sulfate? Yeah, SO4 negative 2. Don't the +2 and the -2 already add up to 0? So that means that I would just have one of each ion to make my neutral compound. So this would be BaSO4. When you're looking at B, silver has an assigned charge. Silver is in that triangle that you drew on your periodic table. What's the charge on silver? +1. So this is Ag +1. Nitrate, the 8 means oxygen is attached to nitrogen. So nitrate would be NO3 negative 1. Don't those numbers already add up to 0? So that means AgNO3 would be my formula. Okay. For C, mercury 2 bromide. Mercury is Hg. The Roman numeral indicates the charge on the metal. So this would be a +2. Bromide, since it ends in "ide", that means I only have bromine with its usual charge. There's no oxygen attached. So this would be Br with a -1. So HgBr2 would be the proper chemical formula. Okay? Do you want to try D, E, and F, and let's see what you come up with? Okay, for aluminum dichromate on E, did you guys put the parentheses in?
Yeah.
Perfect. Okay, D, I need to talk to you about. When you can, if you're crossing the numbers and the charges to get to your formulas, when the numbers and the charges can be simplified, like when they're divisible by the same number, then you have to simplify it. Otherwise, you wouldn't come up with a proper formula. But if you are looking at these charges to figure out how to get them to add up to 0, then you probably realized, okay, you need 2 of the oxalates, and you wrote this, correct? Okay. If you are looking at the numbers and crossing these over, you would have had to simplify this to a 2 and a 1. Does that make sense? Because that's the only way you will actually get the proper formula. Okay? Okay, can I go on? Okay, let's take a look at 2. For number 2, we're going to highlight the metals that require you to calculate their charge. So zinc has an assigned charge, tin absolutely does not, copper does not, sodium and magnesium do, iron does not. Okay, so 3 of those we're going to need to calculate. The other ones we can just run with and name them. Okay, so when we're doing number 2, Zn is zinc. And anytime you guys have parentheses, you want to name what is inside the parentheses. So this OH is written on the bottom left of your periodic table. It's hydroxide. So this would be zinc hydroxide. And then for D, Na is sodium. And then I had you guys write this on the bottom left of your periodic table. It was another way to write acetate. Okay, so this would be sodium acetate. And then for E, what is Mg? Magnesium. And then we would change the ending, instead of writing it as iodine, we would write it as iodide because it doesn't have an oxygen attached to it. Does that make sense? Okay. Okay. Now, for B, C, and F, we need to calculate the charges on the metals. So let's go ahead and do that. Let me change colors here. And remember, we want to start with the non-metal first. So I have 1 oxygen here. The charge on oxygen is a -2. So this would be a -2, which means I counter it with a +2 on the other side. I have 1 tin, so 1 times a +2 would give me this +2. So when I go to name it, this would be tin, Roman numeral 2, because of the charge that we just determined on the metal, and then you would change the ending of oxygen to "ide," so it's oxide. And then for C, we haven't done one that's in parentheses yet. So for C, I have 2 ClOs, okay? The charge on ClO on your periodic table is going to be a -1. When you multiply these together, you get a -2, which means you would want a +2 on the other side. So if I've got 1 copper, 1 times 2 would give me this +2. So when I name this, this is copper, Roman numeral 2, because of the charge on the metal that we just figured out. And then anytime you guys have parentheses, you name what is inside the parentheses. And ClO on your periodic table, it would be the ClO1. Okay, so ClO1 would be hypochlorite. Okay. And then we have one more to do. Letter F. Let's change color again. Let's go to this. Let's go to red. Okay. Be really careful when you guys have polyatomic ions in your chemical formulas, because if you have no parentheses around a polyatomic ion, you technically only have one present. We don't have 7, okay? On your periodic table on the bottom left, Cr2O7 is dichromate, okay? So the charge on dichromate is a -2. So when you multiply these two together, you get a -2. That means I need a +2 on the other side. I only have 1 iron, so 1 times 2 would be 2. So when you name this, this is iron, Roman numeral 2 because of the charge that we just figured out, and then dichromate is the polyatomic ion attached, okay? I think you need practice on this. What do you think? This is a little brutal. Okay, so take a look at ionic compounds with polyatomic ions worksheet. There are 18 questions. The key is on the back.